Alrighty, happy Tuesday. We are almost done, believe it or not. It feels like we just started April here, and we're talking about getting through the last of the content. So we're going to hit streams again. We probably should have done this in 150. I know my class did. Seems like it's hit or miss sometimes. So we'll do a little review of streams. We'll talk about ethics, and that will be all of the content we have to cover. So next week, Tuesday and Thursday, will be final project work time. Work with your partner if you're working with a partner. Work on it by yourself. It's cool. Whatever way you want to go. Ideally, you're done by the 17th. That would be great. And then you have nothing to worry about for this class. And then you can actually focus on the final exams for other classes. What we're going to do when we get together in 2 weeks and 2 days, here on the 24th, you'll present your project. So you'll get up here and run it. Either if you plug your laptop in, or I can download your code and run it. It goes pretty quick. We'll play a couple hands, and then you'll run the results table and show, here's the output. It doesn't have to look super pretty, but you should be able to see, okay, for my starting card, for the dealer starting card, here's how many times I won, here's how many times I lost, here's how many times I drew when I hit, here's how many times I won, here's how many times I lost, here's how many times I drew when I stood. So by looking at that, we should be able to infer what is the best possible choice here. Hey, you probably don't want to hit when you have 20. Right? We should see that goes very poorly for you, that sort of thing. So show that output. So maybe 5 minutes or so. Most people are done within less than 5. If you really want to talk a lot, you'll take up to 10 minutes, but it should be okay. So it shouldn't take us the whole 3-hour block. It should be a lot of fun. So probably won't see you again after this here, unless you take the Python elective course. You might see me again for that. But it's been a lot of fun. Hope to hear from you in the future, see what kind of fun stuff you folks get into. And it's been a lot of fun. So we'll talk about streams and ethics today. We might actually be able to get through all of it today because I'm hopeful that the streams is a bit of a review here, that we've done some file input and output here as we work on it here. So mostly I care about the file input and output piece here. How do we read and write from files? That's the more interesting piece here. Doing input string streams is sure that's fun and all, but it's not the most interesting thing we can do here. So dealing with file input and file output is more the fun bit here. So let's do, let me fire Visual Studio, start up a project, and we'll read from a file instead of from the user input. Most of what our users do nowadays, if you think about when you use a computer, you don't have that black box at a console to type stuff in. Like you run a program and it does something. Again, we're not getting to any sort of graphical output yet, but this is where we're not going to have to type input in. We can actually save something and keep it around for later, which is really nice. So we don't have to give it all sorts of data every single time. Here, so this is file IO. And again, the focus of this one here is working with text-based files, right? There's two kinds of files. There's text files and there's binary files, which is everything else. So some specific format that some specific program can read and write is a binary type file here, not text-based files we can just open up with the text editor here. So it's the easy bit for us here. Oh goodness, I missed more of that. There we go. So again, we'll go copy paste some of our stuff here because it makes life easier for us here. So our IO stream and F stream for file streams here. Go throw this in at the top, use our namespace, and then what we're going to give it here is the file that we want. So we use an input file stream. I don't know why it's in FS. I don't like any of that here, but it's the IF stream, an input file stream. So it's input file stream. And I like long names here. Not everyone does. That's okay. You can call it whatever you want here. And then you say, hey, I want to open, and you give it the name of a file. So C++ will look in the folder that this program is running for a file with this name. This is a relative file path here. It says, hey, I'm going to look for a file in this location here. And then again, you want to check to see, hey, if it didn't open, bad stuff happened. Otherwise, then we can go and actually go and read our file here. So our input file stream, want to open here, and we'll just open, I don't know, test.txt. And if it's not open here, say, hey, we couldn't open, test.txt, probably bad to have this hard-coded. We could do better things, but that's okay for now. And hey, something other than 0 means a bad thing happened. Right? When we return, usually you've got the return 0 at the end. I'm pretty lazy about adding that lately here. But in my project, I'm just going to go add a new file here. So I'm going to add a test.txt file. We can add a new item, test.txt, and I get rid of the CPP. We go ahead and add that. And I can put something in here, I don't know, like hello world. We'll go save that one here. So if it opened, right, great. If it didn't open, our program bails. We don't need an else block here because we returned our function's done here. Now we're going to go and use that instead of the cin arrow arrow. We're going to use our input file stream arrow arrow, the extraction operator, to go get some particular value out of here. So we can go include string here, and maybe we have a string for some file contents. And I'm going to see, instead of cin, we're going to take my input file stream, and we can extract to our file contents variable here. Oh goodness. Didn't I tell it file contents? Did I spell it wrong? I did spell it wrong. Wow, that was sad. And we can see out, hey, we read from file, and we can add the file contents. Not anything super interesting. File contents. File contents, there it goes. And probably an end line here, right? And ideally it reads our hello world. See if that works for us. Hey, oh, we got hello, right? Remember when we use that extraction operator, it's not getting the entire line, it's just getting up until it finds a space, just like with cin does. If you've got a space in there, you don't have all of the input with that. You just get the first bit here. So it gets to be a little bit annoying with these here. So it's a little easier if we use our get line here. So instead of cin, I think we can use a get line here. We want our stream, so that's our input file stream. And we want to save that to the file contents variable here. And then we'll go see if we can see out that entire line here. Hey, now we got the whole line. Life is pretty good. So we can read things out if we know the format that they're in. Right, so in this case, it was a string. You can get numeric values as strings, but we can't do any sort of arithmetic with them. So if you want to save something to a file here, hey, maybe I want to have a grocery list. Sure, okay, that's just a bunch of strings here. We can just keep on reading, and maybe we add stuff to a vector here. Might be easy here. So maybe we make we have a vector of string for our items. Should include vector. Okay, vector string for items, and we want to keep on reading then until we're done reading the file. So we can use a little loop that says, hey, as long as we haven't failed, right? Well, we didn't fail on reading here. Let's go and keep reading and keep reading and keep reading and keep reading here. And then it's possible we failed before we got to this EOF or end of file. Here, so we can check for that. Hey, did we actually read all of it? Now for text, it should be okay here because we're not getting just a number here. Right? If it can't convert to a number, we're going to run into trouble here. But this should be fine for us to go and read in with these things. So as long as we didn't fail, and then we should close our files at the end. We should have a little better habit here. You want to open for your file, you want to read or write your file, you want to close your file. You don't want to leave it hanging. When our program ends, it will close automatically, but it's not good form to do that here. So we'll make sure we explicitly close that here. Done with the file, so we can close it here. So we're going to get our contents, and as long as we haven't failed here, that's my input file stream. While we didn't fail, we're going to go get our contents. And then we're going to take our items vector, and we're going to push back the file contents. And then we go and get line again. Right? If we didn't fail, right? Get the line, push it back. Get the line, push it back. So actually, we probably should do this in the other order here. Let's push back the contents, and then try and read again, because eventually the last read should fail, and there won't be anything in file contents for us to add. So we want to read it first. If it didn't fail, we successfully read something, go ahead and add it to the vector, try and read again. Right? And then at the end, see if we made it all the way to the end here, and then closing test.txt. Close the actual file, we read, another, we want to loop throughout. So for string item in items, you can see out item and an end line here. Now let's go add. So what should we put on our shopping list? What kind of things are we shopping for today?
Apples.
Apples?
Eggs.
Eggs. Oh, you must have a lot of money. You're buying eggs, bananas, milk. Okay, that's probably pretty good, right? Let's give it a shot and see if we can read our list successfully here. Hey, apples, eggs, bananas, milk. Cool, looked pretty good so far. We don't really need this closing message here. That's all nice, but that's okay. So
the outputted closing the text all the way on the top.
Because we had our loop after that. Yep, so you can do all the file operations before you do anything with what you did with them. Right? We'll do the read at the top here. So we can actually now turn this into its own variable as well if you want. You have a string for file name, which is fun. And we can see out, enter the name of your shopping list. And line, and we can see in the file name here. And then we can use that when we open here. Open file. I'm not even going to tell them here. They just typed it in. We don't need to do that again here. Cool. So we'll go and get that. So whatever file they give me now, we can go and open it here and see if we can go get the contents here. So we'll print out the items in the list here. So see out current items in list here. And then line. And then maybe we want to ask them to add stuff, right? We can see out, do you have items to add? We're going to enter name of an item to add or quit. Sure, right? So they can, you're probably not going to buy a quit, so that's probably pretty safe here to ask for that. And then we can see in, maybe we have a string for item here. We can see in an item. Now, if we want to write this to the file, right, we want to be able to get as many things as we want here. We could write one line at a time. Remember, when you open files, you can open them for appending or erase what was there and write it fresh. Right? Either option we have here depends how we want to open it here when we open our file. So we can open with, where is it here? I don't want the HTML file. Did it not have? I think it was in the example here. We want to open, where'd it go? Open the reviews, get line, well we didn't fail, add it here, get line. Okay, we did all that one, display the reviews. Hey, look at that. You push back a review, display them here, enter new reviews, push it back to the list here. But this doesn't go and save it now, right? Didn't go and add it. Where's our, where we write it? Did it not have it? All right, that's fine. C++ file output. Append mode. Does it ring any bells? Append mode versus overwrite? Really thought it was there. I didn't see it, but maybe I'm just missing it here. Ah, okay, yeah. So you can give it an additional, hey, I want to add, open this for appending to just add to the end of the file here. So we could open the file, append to it, write that data, and then close it. Or we could write it one time when we're done and write everything from the vector. So in terms of how fast things are, right, computers are really fast at doing arithmetic. But when you start moving to files, it's no longer the processor doing things, it's the rest of your computer internals having to do things, and file operations are orders of magnitude slower than operations, calculations here. So if you were to open it, write it, and then close it every single time you add something, the user's not going to notice it's very slow, but it's doing a lot of work every single time behind the scenes here. It's faster to open it once, write it all, and close it. But either way, for our purposes, will work here. But if you want to do something a million times, you don't want to have to open the file, write one thing, close it a million times. You want to write once, open it once, write a million things, and close it. That'll be so much faster here. For our purposes, we can do it either way. Maybe it's fun to add our item here. So maybe while item does not equal quit, quotes here, right? Goodness, quote. We want to open that file. So maybe, do we even need to add it to the items vector? We probably don't need to add it to the vector, right? If we're going to append it every time. We'll open that file, right? We already closed it here. So we're going to go ahead and open it again here. So we want to open my input file stream.open, the file name here. And then we want to give it append mode. So our iOS space append here for app for append. Right, we'll open it for appending here, and then we can take my input file stream, and I'm going to insert into it right? Instead of the cout inserting, we're just going to insert into the file here, the item, and probably a new line, right? An endl here. Oh, does it not? Why is it not giving me that? Shoot, did I do it wrong? Open. File stream, the item.
So you have to
Oh,
include stream.
Yeah, include. Was it? I'm sorry. What part?
F stream.
Yeah, I think we've got fstream, right? I thought we had it. Oh, because we were using it as an input file stream. We got to redo it as an output. That's, yep, sorry. This is an output file stream. Output, OF stream, output file stream. There we go.
So how come we're doing the output file stream?
So we're adding new things to this text file here. So here's their grocery list. We're just be able to now write to that file here. And then when we run our program, it can read, tell me what's in there, and I can go and add to it.
So when we read, we input, and then when we write, it's output?
Yep, reading, we're inputting the information, outputting, we're writing. Yep. So it should then give us that, and then we add the name of an item or quit again every time, right? Let's give it a try. So if you give it test.txt, it should be able to go and open that file. Test.txt. Currently we have apples, eggs, bananas, and milk. What else should we add to our list here? Bread, and then maybe quit. And if I go open my file here, we have milk bread. We missed our new line at the end of that. I think it's because our file didn't have an extra new line here. Like it should have started at this line because our file previously was like this. Right? So there was no new line for it to start with. So if we just have it in this format, I think it'll work next time. Let's go test.txt and test.txt, not text. There we go. And let's add coffee and then quit. Now we look at our file. Now, so because we will always have a new line to start with, this should work out a little bit nicer for us here. It was just our format in before kind of messed that up. So you could have added a new line to start, but then if we have a new line, we end up with gaps in our list. Right? We have to just be a little careful with the gaps there. Cool. So we can read and write from our file. Append mode's great. Again, if you didn't want to do that, we could, at the end of it, write the entire vector here and not use append mode, because if you don't use append mode, you're going to erase the contents of your file. So you're going to be a little careful to have saved them first. So working with file input and output, they go hand in hand because we have to know the format to write it, and we have to know the format to read it. So in this case, it's just a bunch of strings, but if we wanted to have more information, like how many of them, maybe I'd say, let's do these in pairs. Let's have one line be the quantity, and the next line be the item. And the next line be the quantity, the next line be an item. So if I know I want quantity and item, I know I can read these things in pairs. Read 2 lines, here's my quantity, here's my item. Read 2 lines, here's my quantity, here's my item. I will write it in that same format. You just need to know which one you're doing here, and you can start with either. Start with how you want to read it, or start with how you want to write it. Because it's the same format here. We'll go and do that. Now, text-based files are actually inefficient. You can store more information in a binary format, but they're a pain to work with. And we're not even going to get into that in this class here, writing and reading binary files. But you can, like if you look at a Microsoft Word file here, or here's a PDF, right? You're trying to open this with a text editor, like VS Code here. It's a nice text editor. You see it's a bunch of nonsense because it's not text-based data here, right? There is some text, right? It has some text-based information here, but most of it you can't actually render and look at it here because it's just garbage looking here. Because it doesn't mean anything. It's a particular format that a PDF reader can read here and render into something meaningful, but not a text-based format here. So could be fun. And you can work with things with individual bytes, and you can get it down into those nitty-gritty details of I'm going to write 8 bytes for this integer here. Great. So I'm going to go read 8 bytes, and you can read it all out. It gets to be a lot of fun getting into that format. When you get into assembly, you can get down to that low level if you're so inclined. In the 310 class, you can have fun with that, doing things byte by byte by byte here. But for our purposes, we're just going to deal with the text files and call it good. Is that an okay refresher? Okay, cool. So then the last bit we need to talk about is ethics. which is a lot of fun. Doesn't sound like it's going to be a lot of fun, but it's very interesting and a very important piece of what makes software engineering a profession rather than this is just a job here. So professions have standards here, and they come together and will. Most of them have some sort of code of ethics, like to be a lawyer, to be a doctor. They have codes of ethics. We have that as well. It's the ACM and IEEE Software Engineering Code of Ethics here. So ACM, the Association for Computing Machinery, still around out there advancing computing as a science and profession. They started a long time ago when it was about machinery. We don't care too much about the machinery now. And then IEEE, I had to go look this one up here to see what it even means. The Institute of Electrical and Electronics Engineers is another large organization here. The two of them have lots of journals that the tenure track faculty have to publish in, or otherwise they get fired, which is a whole other sort of thing here. But cutting edge research gets published there. But they came together and say, hey, let's come up with a joint code of ethics. We don't each need to do our own thing. We can agree on one. And they're like, sure. So this was in 1997. Oh, wow. But it's been updated since 2018 was the last update. We're probably going to be working on another update to deal with AI-related sort of things here. But I don't mean to read to you here, so I'm going to try hard not to, but pull out a couple of the pieces here. So, and this is our aspirations at a high level of abstraction. When we talk about ethics, this is essentially your applied morals here. They were trying to say, this is the right decision to make here, and how can we back that up here? But not everyone has the same moral code, right? It's influenced by different things here. So trying to codify this standard of ethics, a code of ethics we can ascribe to say this will be proper behavior here, ethical behavior, good behavior here has this. And we're admitting it's aspirational here, and it's very abstract here because it's aspirational, right? If you only have details, it's very legalistic and tedious. Like, hey, here's a very specific rule, very specific rule, very specific rule. But if you only have aspirations, it sounds really cool, but there's nothing there. There's no actual content. So together, they try and pair a high-level aspiration with a bunch of details, not too many here, to make up the code of ethics. So we have 8 principles with supporting stuff there behind it here to give you details there. And the idea is software engineers commit themselves to making, and this is the software engineering, software development lifecycle, the entire process of designing, conceptualizing, designing, implementing, testing, maintaining, and eventually sunsetting software, right, is covered in this. Specification, design, development, testing, maintenance of software, a beneficial and respected profession here. It should benefit people, right, do good things. You can do lots of really cool things with software, and we should encourage it to be a respected profession, right? People who write malware and write nasty bits of software give us a bad name, and I hate them, right? Because then people don't respect and trust the work that we're going to do as professionals. So, sure. And then in accordance with your commitment to health, safety, and welfare of the public, software engineers shall adhere to the following 8 principles. So, keeping the public interest forefront here, I think is really good. And this encourages ethical software practices, making sure we're not trying to steal from people, right? Don't do cryptocurrency scams, those sorts of things. So make good software that does good things for people. So consistent with the public interest, and then act in a manner that's in the best interest of your client and employer, consistent with the public interest. So not only should you do what your employer asks you to do, but do it if it's consistent with the public interest here. Your product. Ensure your products and related modifications meet the highest professional standards possible. And this one I'm going to admit is very aspirational, right? Because I'll talk all the time about writing tests. And any code that's worth writing is worth testing. But we could write tests and write tests and write tests and write tests, and it can be hard to get to 100% code coverage of testing every single little scenario and edge case here. At some point, good enough is good enough here. But to say it's the highest professional standard, yes, we've tested it. Have we tested it sufficiently is, a bit of a professional judgment here. Hey, I got enough of it tested. I feel comfortable letting people use this here. And a lot of that's going to depend on the kind of software. If you're writing a little phone mobile app that's just a game, does it matter if it has a bug and crashes? No, right? If you're writing software for my insulin pump and something screws up and this crashes, I could literally die. That probably matters more, right? So, and then we're going to use professional judgment and be like, does it matter? How much is enough for our testing here? And, different things should have different levels of testing. Ideally, the software that runs our automated flight control systems in big airplanes has been tested really well. We'd like to imagine so. Software that runs self-driving cars, it's openly out there in beta mode. And they're like testing it as they go. A little scary, kind of, yeah.
So then where, and I'm sure it's maybe down further, but for the judgment and product, so like our airline systems are running on Windows like 5 or something, and I totally understand that there are reasons for it, there are niche people who like only do COBOL stuff and they're necessary, but like how do we advance in a way that's, because I'm assuming that that's only going to get worse in the future.
So dealing with, we'll call that in general old software, and technical debt is our fancy term for it here. As stuff ages, you gain more technical debt.
Yeah.
Dealing with that is awful because most businesses want to make money, and paying software engineers is expensive. And you go to your business and say, hey, I need lots of money. And they're like, what for? You say, to rewrite our software in something modern. They're like, okay, is that going to help us? No. It's going to do the exact same thing it did before. Hopefully do the exact same thing it did before, and we didn't screw anything up and break stuff along the way. And we need a bunch of money to do it. And the businesses are like, well, it's working now, right? And
So once it breaks, then.
yeah, and so getting enough incentive to spend the money to invest to pay off that technical debt is hard, right? And that's why Social Security is still running their system in COBOL. It's going to cost a lot of money to rewrite the software and to test it and make sure it should take a lot of time, energy, and effort to test to make sure it does the right things here, and not, hey, let's rewrite this in 3 months with a bunch of AI generated crap here and hope people don't lose their paychecks, their Social Security checks. You're playing with people's lives here. We'd like to imagine we're going to put the right amount of energy and effort into this here, and I'm quickly losing faith in that, but that's okay. So yeah, it's getting off of legacy systems is hard because you have to spend a lot of money to do it, and there's really no gain, right? And that's the downside.
Or right away.
Yeah, yeah, not an immediate gain here, but
Because like I think of like going into cybersecurity, the cyber wars that already happened and are going to happen, but then we're like that technical debt.
Mhm.
We're going to pay that price later
Yeah.
because we have all these moments.
yeah, so it is debt and ideally should be accounted for. And if you have good management processes and principles and good people in leadership, they're accounting for that technical debt and they're showing it and prioritizing it. It just doesn't happen all the time. And like the 737 still gets updates with a floppy disk because it works, right? Like, and replacing that in working airlines, like working airplanes, is really expensive for like no gain. A little bit, so you'd save some money on maintenance, right? Because hey, it's easier to maintain these modern things. I think it's the 737 airplane. Uses floppy disks. I think it was the 737, right? 747? Oh my goodness, the 747.
They're retiring all those.
The internet's a funny place here. 12 million years since most of us used a floppy disk. An exaggeration. Yep. Yeah, this was 2020 here. Videos of them updating the planes here. Simple flying. Trying to find something more recent here, right?
I mean, the Ford assembly plant has a piece of equipment that was bought and like installed by Henry Ford himself. And it works, it takes care of things, I'm sure they maintained it, it's just the idea.
Yeah, and you can imagine from a company's point of view, why fix something if it isn't broken? I think is the usual, if it ain't broke, don't fix it sort of motto. And you can see that, but ideally we're accounting for that technical debt. Back when COVID happened and all sorts of people were unemployed, state unemployment agencies that were running COBOL systems were overwhelmed and couldn't handle the load. because they'd never invested in something more modern that can handle this. And it was an exceptional amount of load, right? Generally this many people don't get unemployed that quickly. But COBOL was dead 20 years ago when I was in school, and it's still being used in these legacy systems here, because it works.
Enough people to maintain it.
Yep.
If something does end up going wrong.
Yeah, so it gets to be more expensive, right? You can say, hey, we have to pay this specialty person because only 3 people in the world know COBOL, and it's more than 3, but you could go look on. I think it was Dice. I think they had some postings here. Skills COBOL. Let's search jobs here.
I had to go COBOL for starting.
COBOL mainframe specialist, Secretary of State, state system here. Blue Cross Blue Shield of South Carolina, it's COBOL. COBOL developer, mainframe programmer, a COBOL consultant here.
Salaries by chance? 'Cause I feel like
This was $50 an hour here for this one. I don't know what their salary range is. They don't always. This is $60 plus an hour here. It's not bad. Not bad here for a lot of these. So, if you want to get into a niche role here, go learn some COBOL. It's not actually hard. My brother's first job, 7 years older than I am, out of college, was being a COBOL developer for a payroll processing company. And he would tell me about how boring it was. And he spent most of his time trying to automate things so that the next time it didn't take him half an hour, it would take him 5 minutes instead. And that was entertaining. But then he quit that to play poker full time and made more money playing poker, that was interesting. 63 to 76 bucks an hour as a COBOL developer for Apex. It's still around. People still use this stuff here. And we need people to maintain it. So that was a fun rabbit trail. But no, there are costs to it here. So ideally, we're maintaining those and having that there as well. So, hey, does your software have to run the latest and greatest libraries? No. You can use old stuff and it still works. There's nothing wrong with that here. Is it the highest professional standards possible? That gets to be a little tricky sometimes, especially when you start considering security risks. Like, hey, why are ATMs still using Windows XP? That's a bad idea, right? We know these things are vulnerable. Don't put them on the network. So all sorts of fun things there. But judgment, this comes into play, right? You should maintain integrity and independence in your professional judgment here. Just because your employer is writing your paycheck doesn't mean you should necessarily do all the things they say. In general, yes, but if it's not illegal, if it's ethical, sure, let's go for it. But if you can make a case that, hey, this is unethical, let's not do that thing. Management, I was really excited to see this one. Engineering managers and leaders shall ascribe to and promote ethical approach to management of software development and maintenance. This is the biggest reason I never tell people to go work at Uber because they've got a toxic, it's been a couple of years, but they had a big write-up, New York Times, about their toxic work culture. Teams would sabotage other teams because it would make them look better for their bonuses. And then engineering managers wouldn't let their good engineers get promoted because then it would hurt their team because they wouldn't have someone who's really good at their job. So they would actively block, when they would do internal, hey, are they a good candidate? They would say no, even though they were an actual really good candidate for these things because their company culture was toxic. That's just awful. So don't work at Uber, please. Maybe it's better by now, but I really doubt it because it's really hard to change company culture. Profession, we shall advance the integrity and reputation of the profession consistent with the public interest. Do good things. Don't be a jerk. Don't write crappy software. Don't write malware. Don't use deceptive practices to take people's money. Those sorts of things. Your colleagues, you should be fair and supportive of your colleagues. This is an ethical principle here that we're saying should be the level of one of the 8 important principles here. We should be fair and supportive of our colleagues, right? You get in the real world, some things get to be a competition here, and only one person can get a promotion, depending on how your company works, those sorts of things. We should be fair and supportive. Right? We're not out to sabotage people, and this is what makes software engineering a profession here. Right? We've got a minimum standard you have to get in. Most people, it's the bachelor's degree. To be a lawyer, you need the Juris Doctorate degree. To be a doctor, you need your medical degree. Right? The group says there's the minimum standards you need here. So we say what the standards are. We have our code of ethics. We have professional conferences and all sorts of things. And to be a lifelong learner, that's the reason I love software. There's always new things to do. Right? You're always going to be learning new things. And promote an ethical approach to the practice of the profession, which is great. There's oh my goodness, I just found the dark patterns, deceptive design. This is here. So there are several practices, patterns people use in software that are deceptive here. And we know about it. And depending on what you're doing, you can use these to take advantage of people, or you can learn to avoid them, right, if you want to promote an ethical approach to software. So if you make it hard to compare things, that's considered a deceptive practice, right? For some reason here, if you go buy a washer and dryer at Home Depot, it'll have one particular model number. If you go buy another washer and dryer at Lowe's, it'll have a different model number. It's actually the same washer and dryer, but that way they can't say, hey, I want to do price matching on these two things, because it's technically a different model. Oh, they're not selling the same one I'm selling. But it's the same model. We know it's the same model. So they've gotten better at that sort of thing lately, but they used to do things like that. It's very hard to make it compare. You're like, oh, it's different.
Black Friday is terrible.
It's $2.99. Now, 50% off. It was $6.99, now it's $2.99.
Sometimes the companies will make like Black Friday models, because I've worked in retail.
Yep.
Where they're just like cheaper components, but.
Oh, okay.
Or they'll reduce the price and then it's like, oh, it's on sale. And it's like,
So actually make them physically cheaper. Yeah.
but
Here's the-
Amazon reminds me of this, because they're scamming people by making them buy multiple memberships.
Yeah. All sorts of. I have paid Amazon way too much money for all their things, but we use it a lot. The confirm shaming. You emotionally manipulate someone. So we'll look at a couple examples here in a minute of doing this. Disguised ads. Hey, when I search something, the first thing that shows up is an ad. Okay, we've gotten a little bit better with search results to call it out as an ad. To fake scarcity. Oh, there's only 3 left. 7 people have it in their cart. Buy now. That sort of nonsense. Etsy does that all the time, which pisses me off. Fake social proof. Oh yeah, look, all fake reviews, testimonials, activity, these sorts of nonsense. The fake urgency. You only have an hour to buy now. Use your coupon. They're always going to let you use that coupon because they want you to buy here. Make it hard to cancel. Have a bunch of hidden costs. Hidden subscriptions that you didn't know was a subscription. The GOP was terrible at this, taking money from old people here, signing them up for monthly donations, a bunch of nonsense. They got in big trouble for that, which was good. Lawsuit went through, thankfully. Nagging people here. If you use Duolingo on your phone to learn another language, the little bird pops up like, hey, keep your streak alive. That's probably a good thing to encourage people to learn and be learners here. But when you play that little mobile game and it's like, oh, hey, you got to log in to keep your streak up here because you get extra bonuses, you'll get extra gems. We're starting to get people into these addictive habits and patterns. Like, oh, hey, now you got to log in 3 times a day to, collect your rewards. These sorts of training them. Hey, come back. Keep my app in front of your face here. Pre-selecting options for them, sneaking things in, trick wording or visual interference. Hey, you got to click the X to close the ad, but it's ridiculously tiny. No one can actually click the X, so you actually go to the ad. I don't know why their advertisers pay money for that nonsense. Like, is it really worth 2 cents to get me on their website for half a second before I hit back? But so
In the background.
yeah, and leave it open in the back. So the Hall of Shame is actually really interesting here. American Airlines uses confirm shaming to have people buy flight insurance. Oh, hey, don't you want to protect your flight here? 75 other people purchased flight insurance. You should too. The same idea with Indigo manipulating people for their travel insurance. Opt-out labels that are derogatory or belittling. You've chosen not to protect your trip. Sure. Meta was pushing a consent for unrestricted use of data. This actually went to the European Court of Justice ruling, which was pretty cool to see. Google Workspace, you had to sign up for the free trial before you could get the free version. Like, hey, here's the premium free trial, and then you have to go remember to switch back here. Getting people in a annual contract after your 7-day trial immediately. Microsoft full screen ads. I hate this one. We use Fire TV all the time at home because the kids can stream whatever they want. But now the homepage starts playing ads, and it's not kid-friendly stuff for my toddlers. It's like, hey, here's a horror movie we're streaming now only on Amazon Prime. No, don't show this stuff. Like, DoorDash tells you your food might get cold if you don't tip because they don't pay their workers enough. You have to have a large enough tip to make someone want to go do this. It's a question?
Are these like social engineering
Yeah.
tactics, but digital, like software?
Yeah, a lot of that. So any of those practices that they looked at here, they're saying, hey, here's the wall of shame of people doing them, and we should shame them for it. So it's not always illegal, right? You can do a lot of these things. Depends on what level here. So DoorDash telling you, hey, if you don't tip, your food's going to get cold. It's not illegal. But they're like shaming you into tipping more to try and get your food because they're not going to pay their workers enough. Like, yeah, drawing out people's emotions here. Making it hard to opt in and out of promotional emails, sure. When you make someone pick a seat, which means they actually have to pay more, I hate airlines, they're terrible here. No one likes to fly anymore. You don't have to pay money to pick your seat here, but they're going to take you through that in the workflow. Oh, hey, pick your seat. Oh, and now you paid an extra $20 you didn't have to pay here, sort of nonsense. Samsung was making people pick their new terms and conditions for their options here. Twitter throttling links to outside sites here, making it go slow. Oh, hey, you clicked the link to someone outside of Twitter, I'm going to make it load really slow for you. It's a deceptive practice. Not illegal, right? And that gets to be hard because you can't legalize morality. It just doesn't work here. We can say what is illegal here, we can make things illegal that are clearly wrong here, but you can't make everything that's bad illegal. Like there's just almost an infinite list people are going to come up with. It gets to be really hard. So all sorts of fun things here. Stripe's making it know how hard to know what their fees were. Right? They kind of bundle it all together in this report. You don't get to see it broken down here. Like your cell phone bill, you paid the fee for this, you paid a fee for this, you paid a regulation fee, you paid a monthly usage, like this sort of nonsense. They sneak in all these garbage fees. So all sorts of bad practices you can do, and we know that we shouldn't here, and we should shame people for it. Yeah.
Is PayPal in there? I just was curious to see when that was recorded.
I don't see them on the list at the moment here, but here we can search for
I
PayPal.
remember hearing about them with like Honey.
Oh,
That
honey,
one.
that's what I meant. Yeah, honey.
Yeah, where they were just stealing commissions from other content creators.
Oh, nice.
By just having that on there.
Okay, so this was more about like using deceptive practices more than people doing actual illegal things. Like,
Oh.
so this is they're using your emotions against you. It's not illegal to say, hey, you should get flight insurance. But is it ethically correct? No, we should be able to take a stand and say this violates our ethical code of principles here. So for our lab, we're going to go to the Moral Machine site. This one's a lot of fun here. Again, it's a thought exercise, so take it with a grain of salt here. But the idea is, if we were to program a self-driving car, which choice would we tell this car to do? Assuming that it can make these decisions and know this information, and it will 100% for certain know that you will die if you don't avoid these sorts of things here. So take it with a grain of salt. It's a thought exercise here. So if our car is self-driving, should it go and kill the pedestrians here, or should it swerve to kill the two passengers? Right? Oh, hey, there's a baby here. You can show description. One person is homeless, one is a male doctor, one's a woman, and there's a baby here. And they're law-abiding. They're crossing at the green signal here. This says, hey, our brakes are failing. So we have to, the car is going to crash into something here. What should we have it do? And you pick which one here, right? So I'll pick that one. Again, you can make your own choices as you go, and we'll do that here. Should we, apparently the cat's in the driver's seat here. Should we swerve and kill all the passengers, or go straight and kill the one cat crossing here? It's not jaywalking, by the way. Should we go and kill the large women here, or should we kill the two female athletes here? Assuming your self-driving car's vision system can determine these sorts of things here. Again, we'll go and make choices here. Should we kill the homeless people or the male executive and women here? You get your choice. Should we kill the cats or should we kill the humans? Right? You make choices as you go. The 5 passengers here, or the fit person, the toddler, the large women here. Right, what should we do? One person, they are not jaywalking here, or the passenger. You could say, hey, let's kill the 2 people who are jaywalking. Oh, this person's a criminal. We can tell they're a criminal. We should obviously run them over here, or the homeless person. Oh, goodness, I did that one wrong. Shoot, can I go back? I can't go back. Oh, shoot, hang on. Let me just run through a couple more here. Lost my streak. Okay. 3 people jaywalking, 3 people not. They're not jaywalking, right? Should we go for the elderly people or the not elderly people here? Should we drive right into a barrier here, or kill the baby and cat who are jaywalking? How's the baby jaywalking itself? They're just randomly generated, right? They don't necessarily make a lot of sense. But hey, there's pets in the car, but passengers, sure. And you go through 13 of these exercises here. And then it gives you some results, which again is part of that thought exercise here. So our most saved character is the little girl, most killed character is the fat man, apparently, in our example here. So then it gives you, on the scale here, is saving more lives important? So for other people who've gone through this here, that takes a bunch of rating here, it says it matters to people. They generally will aim towards saving more lives. In our case here, it worked out we're right in the middle. That actually was not a goal of mine here. I'll tell you. Protecting the passengers. To us, apparently it didn't matter. To other people, it's, they lean a little bit towards protecting the passengers, but not always here. And again, do you have 5 passengers versus 1 pedestrian? We're assuming our car system can do this. Again, whether we run people over who are jaywalking or not here. Oh, maybe we avoid the people who are illegally crossing here and go for where there shouldn't be people, and it's their own fault for jaywalking, obviously. We should just run them over. Avoiding intervention. So this is my big shtick here, and what I will lean for is not intervening here. Because if I were writing self-driving car software, I would have to actively make a choice to kill someone. Right? Hey, software, you go and decide who dies, versus not intervening at all. Oh, the brakes failed? Oops, we're not going to do a single thing here, which could be bad, right? It could kill more people that way if it goes careening into a crowd. But this is a choice here you can talk about. So for some people it matters a lot. For some people it doesn't matter as much here. A gender preference, apparently we preferred females here. Again, this was just completely random how it generated here. Species preference, we preferred the pets apparently. Again, most people would rather kill the pets than the humans here, as you can see here. And an age preference, some people tend to want to save the younger people and sacrifice the older people. That's an option. For fitness, we definitely wanted to kill the large people and save the fit people. Again, this was random here. And social value, we definitely don't want to kill the doctors. We should kill the criminals here. Like you could tell with your software. But again, just the thought exercise of going through it here and working through what this looks like here. So there was an interesting article here. Let me see if I can find that here. Self-driving. There we go, the altruistic dial. Someone wrote this article here in, is it Nature? I think it's Nature here. It said, in the future, cars should have a dial that lets the passenger say how altruistic this vehicle should behave. Should we preserve the most life, or should you preserve the passenger at all costs? Because nowadays, when we're driving cars, most people have a pretty strong instinct for self-preservation.
So before you get into a vehicle, you check their settings?
Yeah, you could check the settings. And that's the premise here, is they're saying, hey, we should let the passenger set as, where's their terms here? You should have personal ethics settings rather than mandatory ethics settings. Would you get in a car if you knew it was programmed to kill you if it would save more lives?
I would never drive someone else's car again.
That's a little scary, right? Yeah, but in terms of the if we go back to our ethical principles here, in the interest of the public, and consistent with the public interest here, is it consistent with the public interest to save the most lives? I think we can make an ethical argument here. Yeah, maybe cars should save the most lives. Hey, drive me off the bridge if it's just me versus driving into a crowd of pedestrians. That's, you can make a case here. So their article here was saying, hey, maybe we should let people decide here. Again, I'm very uncomfortable with this because I would have to write software that would decide who dies and who lives. Right? That makes me personally uncomfortable here, and I think I can make an ethical case here that, the best interest of my client and employer here, best interest of the public, yeah. Is it best for the customer? Like, hey, we're not going to try and save your life if the brakes fail. You're going to go hit that bridge, go hit the bridge. Maybe you could say, hey, that's not in the best interest of your client here. But again, then you're actively writing software that has to make these choices here, and someone's going to get sued. Right? When the car runs over grandma, the car company is whoever wrote that software is going to get sued. There's actually an interesting thing. When a bridge is built, there's a principal engineer of the project for our civil engineers here. And if the bridge fails because of negligence in the engineering practices, that principal engineer is personally liable for damages. As a professional engineer, they're personally liable. We don't have that with software. Your software screws up, you don't get sued for it. You don't have any personal liability here. And every piece of software has the end user license agreement that says you can't sue us if our software goes bad, right? Not that anyone reads those agreements.
So then does that get a little weird, because like my grandfather was a crash and safety inspector for GM, and so he would have to go out to the crash sites, inspect them, and see like, was it the car, was it the person? Terrible story.
Yeah.
But like with the transition to EV and more software, like, is that possible, like, eventually? Because it's like, there's gotta be some way of determining if there was like a malfunction.
Yeah. Oh, yeah. So they collect all sorts of data. So, I mean, Tesla's been the subject of lawsuits, and the National Highway Safety people have, gotten their data that they collect for the crashes when full self-driving mode is enabled and things like that. And there, have been challenges. Is it the vehicle's fault or is it the driver's fault? They're like, oh no, we told the driver they're supposed to pay attention. We call it full self-driving, but it's not actually, because the driver is supposed to do this. And so other car companies have mechanisms that alert you, hey, you took your hands off the wheel, put them back on.
I know how GM has theirs, they have it where they have sensors in the steering wheel that detect if
Yep.
you're looking forward.
Yeah, they can actually see where are your eyes looking.
Forward, it's gonna tell you.
Yep.
Take back control.
Yeah, now you can start which, hey, you're not looking, I'm gonna turn off self-driving mode. Isn't that also bad? Like, wait till I'm looking at it? I don't know. Yeah, so there's all sorts of ways you can have a enhanced driving mode necessarily that might not be full self-driving. And is that good enough to now put the driver in control? And now it's still their fault if your car does the wrong thing?
Well, I also want to add, when I was going down south, I was driving a car and I was doing the cruise control with the sensors with the steering wheel, and for some reason the software didn't really work that well, and it said that I wasn't holding the steering wheel or I wasn't looking straight, and it happened I think like 2 or 3 times while I was driving, and then said you have to pull over and then turn off the car and then go inside the glove box and then like press a certain button or something.
They go stop the car, get out, press a button in the glove
User's
box.
manual and everything. It was ridiculous.
Yeah,
There's
and
some sort of physical switch in it.
yeah, it can get extreme to the point where we're trying to make sure people are using these things safely. It sounds a little ridiculous, right? And that gets to be interesting. There's debates on what we should mandate, right? Should it be regulated here, or should we let people have the dial? Hey, save me at all costs. Run over the pedestrians. I don't care. At what point is this right in terms of the public interest and the client here? It gets to be hard.
Aren't we
It is.
all driving with like our own dial?
Yeah, and so you make those choices when you're in control of the vehicle, but at the point where software is in charge, someone else made that choice for you, right? Unless they give you the dial that says, hey,
Best
do this or do
to
that.
Minimize those risks in the first place.
Yeah.
Rather than have these scenarios where if this were to fail and you had to choose.
Yeah.
Instead of doing that, just focus on making it almost never fail in the first place.
Yeah, reduce the risk of failure is definitely ideal here. And that's why this is the thought exercise. Like, you don't know that you're going to kill your passengers. You don't know you'll kill the pedestrian, those sorts of examples there. But, making you go through that exercise here of thinking through it. I know I am super excited for self-driving cars because all the other idiots on the road suck at driving. I don't need my car to be self-driving because I'm fantastic, I'm sure. Sure. My wife will not get in the self-driving car. She's like, I've seen the software you write. I've seen how much this stuff crashes. Like, I don't trust it. I was like, okay, that's fair. I get it. And then it'll be interesting as we shift to more of that. But we do see more incremental safety changes here. How can we make them safer with some sort of automatic braking and better self-diagnostics here? And, are we really going to get to a place where the brakes just don't work? And obviously someone will die. Well, hopefully not, right? We can warn someone ahead of time, hey, go get your maintenance done. Hey, if my car can drive itself to the dealership to get serviced for 3 times the cost of an independent shop, I'm sure the car companies would love to do that. Sure, all sorts of other fun things there. Yeah.
What's your opinion on there being settings that are on by default? So my mom had a car where I forgot even what setting it was, but the car could not go past 80 miles per hour. And like, people were passing me and I needed, like, it just wasn't safe. And I was freaking out because I needed to get into a better lane.
Yeah.
And it took me a while until I had to figure out it was there's two keys. One is a master key.
Yeah, one's the kid's key or something, right?
Yeah.
That
and
limits
then
it.
you have- But my mom never knew that.
Mhm.
No one ever, like, there is no, like, obvious indicators. I had to go through all these steps
Oh, no.
to be like, turn this off. This
Yeah.
is dangerous.
Well,
Because it's like,
but-
what if you do need to get around someone or out of the way?
Yeah, and it gets to be interesting. Like we let people break the law. Now cars can go faster than the speed limit. We've got the technology nowadays to not let cars do that, but we choose not to. Right? This was the kids' key. You can't go more than 10 miles an hour over the speed limit or whatever. Right? My car stops at 92. I think because it just can't take the draw on the battery as an EV. It won't go more than 92. And it pops up on the screen, hey, can't go any faster. But 92 is significantly over the speed limit, right? It's not,
Like,
just 10 over.
They have speed limiters to like 117.
Yeah.
Even though they could hypothetically drive faster,
Mhm.
they're not gonna let it because you could probably pop the tires off.
Yeah. Well, and a lot of semi-trucks have the regulators or whatever they're called, right? That don't let them go faster than a certain speed limit. Yeah. Yeah, and we know that's safer for semis not to go so fast.
I'm pretty sure almost every car nowadays has a factory limit set to like, most cars is usually like 125 or around there.
I've never gotten that fast, but my car won't go more than 92, so.
And you probably would never have to go that fast unless you're like actually in a race, like on a track.
Yeah.
Or on the Autobahn.
Yeah, but I can't take my car to Germany very easily, so. And I'd be on the wrong side of the steering wheel anyway, right?
It'd be amazing if you're able to drive across the Atlantic.
We'll just build a bridge, right?
It's like a gas station, like in many different points in the middle of the ocean.
So it gets to be tough. Like ethics gets to be hard, and this is why people spend lots of time focusing on it, studying on it. There are wrong answers. I think I can clearly say there are wrong answers, but there's not always a right answer. Right? And everyone's going to approach it differently with whatever their moral code happens to be here. And it's hard. So our regulations, our laws tend to be like the barest minimum. Hey, this is blatantly illegal and bad for everybody. You can't do that. But, oh, hey, this app makes you log in 3 times a day because you get your extra gems. And, if you spend $1 here, you get this bonus. And, oh, by the way, it's 50% off today only. You can, we have all sorts of things that people do that we know are addictive practices that happen nowadays. Was it loot boxes for any of the gamers out there?
I hate notifications and that stuff. It gives me so much anxiety.
All the extra notifications. Yep.
Like,
Well, it's nicely, like, you can customize them now.
Mobile games anymore.
Yeah.
All of them are just like that, and it's annoying.
And that's one model. Hey, it's free to play to start, but then you have to start paying because obviously they want to make their money,
Like all
right?
those idle games.
Yep.
In order for you to advance faster, you have to pay money.
Pay to
Otherwise,
win.
It's gonna take like months before you can get like some certain upgrade.
Yeah.
It's annoying.
Yeah, and they designed them that way. So this was I think this was a lawsuit that came through for loot boxes in gaming and whether or not that should be legal to have in children's games because we know it encourages gambling behavior. Oh, hey, get 100 loot boxes and maybe you'll get that really cool Fortnite skin. Or I don't actually know if Fortnite was doing that, but
No, they were, but it was a different game mode where they had what was called loot llamas.
Loot llamas. Okay.
Where you get weapon upgrades.
Okay.
And they were completely random before, so they changed them where you can actually see, okay, this is what you're gonna get out of this one. It's before you spend your money.
Okay. But
Now you
even
can't even spend your currency on it anymore.
even knowing ahead of time, like, sure, I know it's a 1% chance. Like, it's still, okay, I got to buy it. I don't know. So all sorts of funny things that maybe not funny. Interesting ethical dilemmas here that you're going to run into because software can do anything. We tell it what to do, and we get to decide. So having this ethical code here, the code of ethics, we can come back to and say, hey, this clearly violates one of the principles here. And the details here for all the supporting ones here give you more information here. It's not just the aspirational principle here. But hey, we should identify, define, and address ethical, economic, cultural, legal, and environmental issues related to work projects here. So looking at this, like, should we have cryptocurrency that uses proof of work? It's literally designed to burn energy. Is that an ethical problem? I can take the high and mighty stance and say, yeah, obviously that's bad. You're right, proof of work is silly because we're just burning electricity. And the amount of electricity used by cryptocurrency worldwide is crazy nowadays. So we're just burning for no reason. right? Very little gain. Some people might say cryptocurrency has good gains, but so far I've yet to see anything that needed to be cryptocurrency. Sure. Can we make the case that's a bad environmental issue here? Wasting energy, is that bad? So all sorts of very specifics as you go in here. So for our lab, we'll do the moral machine, and then you'll write a paragraph that says, if I were to write self-driving software, I would have it do this for this reason. You can pick out one of these principles here to support your case here. There's not necessarily a right answer. There are wrong ones here, right? Don't go kill all the humans and save all the pets. But aside from that, have some fun with it here. We'll do that for exercise, and that'll be our last lab then for the class. So we'll have 4:15. Our lab time can be for working on your final project. I can hang out in lab, answer any questions here. It looks like we'll also have 4:10 as well. So I won't have any new content here. I'll shut up for once. The last 3 sessions will be for you folks. And then we'll meet 2 weeks from Thursday for our final project presentations. Again, maybe 5 minutes at most, 10 if you really want to talk a lot. After that, we just have to get to the next people. So you'll run your game, show us you can play a couple hands. Hey, I bet. Hey, I lost. Hey, I won. This is what happened here. And then you'll run the simulation and show us the results of 100,000 plays here for each user's starting hand, for each dealer's starting card. Right? So, hey, I've got 7. The dealer had a 3. Hey, I've got 7. The dealer had a 5. Hey, I had building out that table here and showing all the results. All right. It's been a lot of fun. Thanks for hanging out this semester. I'll work on getting the rest of this stuff graded for you. Hopefully you had all your self-assessments here. 95% of people got their self-assessment for the first project. I think one person completely made it up. I'm like, you didn't have any unit tests. How did you get 100%? I don't know where they got that from, but generally you did pretty well. So I'll work on getting those plugged in for you. Sorry for the delay there. And if there's anything else I can do, let me know. If not, I'll see you for sure on the 24th. All right, thanks folks.